The next part of 2.4 deals with transformations. Transformations of functions I think are fairly simple to see. You just kind of have to get the hang of what all of the different pieces of the function mean, okay? So what we need to do, there's going to be some easy steps that we can follow to sketch the transformations and to just kind of see what's going on with the function. The first thing that you're going to want to do is identify what the parent or the original function was. Did it start out as a line? Did it start out as a parabola? What was the function, okay? Then you want to make sure that the equation is in standard transformation form. So I'm going to show you how to do that here in a second. You're going to want to make sure that the numbers are in the right place, the coefficients are in the right place, and it all looks the same, okay? And then we're going to sketch the function using, they call it, dear Aunt Sally, it's PEMDAS. So using the PEMDAS rules, showing where the features of the graph actually happen to be, okay? PEMDAS never goes away, okay? But your standard transformation form that we're going to look at is this. So if you have a new function, so this is the new function, okay? All right, so this is the new function. Your original function was the f of x that was in here, okay? So you'll see the f of x that's in here. But then you'll notice all of the things that they did to that. They multiplied by a outside of the function, okay? They multiplied by b inside of the function. They subtracted c inside the function, and they added d outside of the function, okay? So this is outside, inside, inside, outside. And it's gonna be very important for you to determine if it's inside of the function or outside of the function. And here's a little bit of below that is a little bit of an explanation of why it's important, okay? There's two things that you've got to understand. If it's multiplication or addition, this could also be division. This could also be subtraction, okay? And if it's inside or outside of the function. So hopefully this is something that your Algebra 2 teacher took care of pretty well, but it doesn't hurt to go back and take a look. So here we go. So if you've got multiplication versus addition, if you'll notice up in our original function up here, our new function, a and b were both multiplied, right? And c and d are being added or subtracted. It doesn't really matter which one. Multiplying changes the shape. It changes how tall. It stretches or shrinks the function. So stretch or shrink. They also sometimes call that expansion and compression. It's also called a dilation. So anytime something's being multiplied, you're changing the shape of the graph, okay? If you're adding, you're changing the locations of the graph. That's called a translation. So it's either shifting to the left, it's shifting to the right. So these are the shifts, okay? So they're shifting left, they're shifting right, they're shifting up, they're shifting down, okay? Like the rules for PEMDAS, this is an old school notes, dear Aunt Sally. So like the rules for PEMDAS, you're gonna follow and sketch the new graph by those transformations. You've got to do multiplication before you can add. So anytime you're doing that, you're gonna multiply the function, so stretch it first, then shift. So stretch, I'm gonna write that over here, stretch, then shift. If you do it the other way, it will change what your graph looks like, but stretch, then shift, just like it would be if you were doing PEMDAS, okay? And once you understand the sequence of the transformations, we should be able to sketch the transformations without having to go through all of the different transformations, okay? The other thing that we need to make sure we're being careful of is the inside versus the outside. So looking at this equation, notice that the A and the D are outside, and the B and the C are inside, okay? Anything that is inside the function affects X, okay? And it affects X, it's down in this next step, but it affects X in the opposite way of what you would think. So if in this section I had X minus 2, you're actually gonna add 2 to all of the X's, okay? If I have 7 times X, you're actually gonna divide all of the X's by 7, okay? On the outside of the function affects the Y values, okay? The affects the Y values, and you do exactly what it says. So if it says on the outside plus 7, you add 7. If it says on the outside you multiply by 2, you actually do multiply by 2. So you do exactly what it says, okay? So inside you do the opposite, outside you do what it says. Inside affects X, outside affects Y. All right, so let's take a look at an example right here so you can kind of see what's going on. So they want you to identify the parent function and then write the equation in standard transformation form, so get everything where it's supposed to be, and then identify the values of A, B, C, and D, okay? So let me rewrite standard transformation form on this page so that you can take a look. So g of x equals A times the function of B times x minus C plus D. Okay, so you'll notice on this equation that the part that's added, the plus whatever, is in the front. Okay, hang on. Let's take this step by step. I'm getting a little ahead of myself. The first thing they want me to do is identify the parent function. The first thing I see is the fact that there is a square root. So that tells me that the parent function was f of x equals the square root of x. Because that's one of the 8 parent functions that I know. They're not going to give you one of them that we have not just talked about, okay? So this is one of the parent functions. So what I need to do is get this function at the front, and anything that's added to it needs to go to the back. So this plus 3 really should be in the back. So let me rewrite this in standard form. So this is now h of x equals 1/2, and I'm going to put the square root, but I'm going to leave it blank because we've got something we've got to do to that. And then I'm going to put plus 3 in the back, okay? Now, if you'll notice in this equation, this x has a coefficient of 1. Well, the x that's in here has a coefficient of -4. I have to make this x have a coefficient of 1 to put it in standard transformation form. So coefficient of 1, okay? To put it in standard form, it's got to have a coefficient of 1, which means that I've got to divide all of these things by -4. When I do that, I'm going to pull the -4 out to the front. When I divide the x by -4, I get 1. When I divide the 2 by -4, I get -1/2. So this is my equation in standard transformation form. And now all of these should match up with one of the letters here. So you'll notice that this is A, B is -4, here is C, and here is D. So let me write those down. So A is going to be 1/2, B is going to be -4. I want you to be careful with C. Notice in the equation that this is negative. So since in the equation this is negative also, the C is just the 1/2. Okay, so that C is going to change signs every time because it's minus in the equation. All right, so if, for example, this had been x plus 1/2, the C would have been -1/2 because the negative and the negative would have changed it to a positive. All right, and then the D is 3. So these are the values of this function. Okay, in the next example, what they want me to do is they want me to do those same transformations to this parent function, okay? Well, this first one, so they want me to do the same thing. So they want A to be 1/2, B to be -4, C to be 1/2, and D to be 3, but they want me to apply that to these different functions. So here we go. So the 1/2 has to go on the outside. So this is 1/2 f of -4 times x minus the 1/2 plus 3. So this would be the function f of x with these a, b, and c, and d values in standard transformation form. So I just applied the a, b, c, and d to this function, okay? So let's do that to this one. So let's say f of x is, so this was x squared, so now I have to apply it to that. So the 1/2 goes on the outside. The function is x squared, so this function gets a -4 in the front, and then it gets x minus 1/2. That gets squared. All of this, remember, goes inside, right? Just like all of this was inside up here, it's the same thing. And then the plus 3 goes on the back. So all of this has to go inside of the function. So this -4 times x minus 1/2 replaces the x. And you're going to see that that happens in every function, okay? So let's take a look at C. So I'm going to put the 1/2 in the front, okay? And then all of this, -4 times x minus 1/2 squared, all of this part this part right here, is going to replace the x. So this is negative 4 times x minus 1/2. And then a plus 3 gets stuck on the back. Okay? We can actually simplify this a little bit. If I do 1/2 times that, I could multiply it in. But since we're just doing transformations, I'm going to leave it like this, and that's okay. Let's take a look at D. X cubed. So again, 1/2 goes in the front. My inside is negative 4 times x minus 1/2. And we're cubing that plus 3. Okay, so we're replacing that x that was cubed with my transformation of the x. All right. This one's a little bit different because the x is inside of the natural log. So it's the same process, but I feel like it always distracts people because there's extra letters with the natural log. So this is going to be still 1/2 times the function. Well, the function is the natural log, negative 4 times x minus 1/2 plus the 3. Okay, so we're putting that 1/2 and then that piece of the function and then finishing that out and then the plus 3, just like we've done for everything else. Same thing with this one. The x is going to get the negative 4x minus 1/2. So this is going to be f of x equals 1/2 e to the negative 4 times x minus 1/2 power plus 3. Okay, so hopefully that makes sense, writing equations of the functions, seeing where those things happen, and transforming functions using parent functions and standard transformation form.